This is part 2 to the Enzymes lab, performed by Neil and I. So the experimental design, we had to design 3 experiments to find out the preferred temperature, pH, and salinity for the enzyme catechol oxidase. And to back up a little bit, catechol oxidase is an enzyme found in many fruits. It reacts with catechol to make a brown product called benzoquinone. And whenever you leave a piece of fruit out, cut open, and it turns brown, that's what causes it. So for temperature, our hypothesis was that as the temperature increases, catechol oxidase will denature and it will become ineffective because enzymes need have specific conditions to work under. So the procedure for testing the efficiency of catechol oxidase in different temperatures. First, we had to label 6 different test tubes, 1 through 6, and then we placed 1 milliliter of potato extract, which is catechol oxidase, in each test tube, because first you had to affect the enzyme in some way, and then test how effective it was by adding catechol after you change it in some way, or after you alter its environment. If you place catechol and catechol oxidase and then altered its environment, you would not get an accurate reading. So we placed test tube number 1 in an ice bath at as close as we could get to 0 degrees. We placed test tube number 2 in water at room temperature. Room temperature is about 20 degrees. We placed test tube number 3 in a hot water bath of 40 degrees. We placed test tube number 4 in a hot water bath of 60 degrees. Number 5 in a hot water bath of 80 degrees, and test tube number 6 in a hot water bath of 100 degrees. And after 10 minutes of letting each test tube sit in its environment, we added 1 milliliter of catechol to each test tube, and then placed it back in its container or environment. And then after another 10 minutes, we observed the production of benzoquinone. So here are the test tubes before we added catechol, and here are the test tubes after we heated them and added catechol. As you can see, as the temperature rises from a certain point, as the temperature rises, there's very little benzoquinone production, which is produced, as we know, by catechol and catechol oxidase. So 100 degrees, very little benzoquinone production, but as you can see, at 40 degrees, it's the darkest, so we had a lot of benzoquinone production. So next, we tested for pH. And our hypothesis for this was that the ideal pH of catechol oxidase is 7. So pH is above or below 7 will denature it, making it inefficient. So the procedure to test for pH was to label 7 test tubes, 1 through 7, add 1 milliliter of potato extract, again, or catechol oxidase, in each test tube. We added 1 milliliter of pH buffer 2 to test tube number 1, 1 milliliter of pH buffer 4 to test tube number 2, 1 milliliter of pH buffer 6 to test tube number 3, and pH buffer 7, 8, 10, and 12 all the way up to our 7th test tube. After a few minutes of letting the pH buffers affect the enzyme, we add 1 milliliter of catechol to each test tube, and after another few minutes, we observed the production of benzoquinone. And this is what we got. Now, in this picture, it's a little hard to see because it's farther away, but we can go closer, and you can see that this one, although other ones may appear more orange, this one was the darkest of all of them. Right here, test tube number 3, which had a pH of 6. As you can see here, the highest pH, again, had less benzoquinone production. So next was salinity, and our hypothesis was different salt concentrations will affect the way enzymes function. The procedure for this was to label 5 different test tubes, 1 through 5, to place 1 milliliter of potato extract into each test tube. Then we had, at our, available was a 10% sodium chloride stock solution, so we would have to dilute that to 2%, 4%, 6%, and 8%. Then we would place 1 milliliter of the concentrations, 2% to 10%, into the test tubes 1 through 5, respectively, 2% into test tube 1, and so on. After a few minutes, we would add 1 milliliter of catechol each test tube, and then observe the production of benzoquinone. Unfortunately, we couldn't get to do this experiment because we didn't have enough time. So our conclusion for these experiments was that the optimal temperature for catechol oxidase is 40 degrees Celsius. We know this because the test tube that was placed in a 40 degrees Celsius water bath turned the brownest, meaning the most benzoquinone was produced. Our hypothesis, what we stated, was correct. As the temperature rose from 40 degrees, we were mostly correct because as the temperature rose from 40 degrees, as it went higher and higher, the amount of benzoquinone decreased. But you could also say that from 40 degrees and under, the amount of benzoquinone decreased. So from 0 to 40 degrees, it went up. The amount of benzoquinone went up. So generally speaking, as the temperature rises, the enzyme denatures more, but there is a window, like I said, for 0 to 40, whereas the temperature rises, the amount of benzoquinone, or the catechol oxidase activity, increases also. And we conclude that the optimal pH for catechol oxidase was 6. We know this because the test tube with the pH with the buffer of for a pH of 6 turned the brownest. Our hypothesis was incorrect because we predicted that the pH for catechol oxidase was going to be 7. And from our results, we also know that very high and very low pHs denature catechol oxidase. We don't know the optimal salinity for catechol oxidase because we didn't have time to test for it. And that's the end of our presentation. I know you don't grade these until after a while, or a while after we submit them. So by the time you hear this, hopefully the Cardinals will have their season back together. And, well, I think we know where the Eagles will be.